Okay, so hello everyone. In this video, we will be solving the question number 2996, which is the smallest missing integer greater than sequential prefix sum. The question is marked easy. It is very easy to understand as well. Constraints are also very small. So we will first understand the question, then understand the examples, and then we will form the approach. So let's quickly do all of them and solve the question. Okay. So what we are given is that we are given a zero indexed array of integer nums. Okay. A prefix nums 0 to I. Prefix always start from the beginning. A prefix nums 0 till I is sequential if for all j which is greater than equals to 1 and is smaller than equals to I satisfies a particular condition, which is that nums of j equals to nums of j minus 1 plus 1. It means that nums of j is just greater than prev element. Okay. In particular, prefix consisting only of nums 0 is sequential. So let's first understand. Suppose we are given a nums a, b, c, d, e, f, g, and prefix always starts from beginning. So it starts from index 0, and we need to construct a sequential prefix array such that for nums j equals to nums of j minus 1 and plus 1. If for j equals to 0, minus 1 index does not include, so index 0 is already included, which means that nums of 0 is pre-considered. Okay, and our j will start from 1. Okay, and we need to form prefix array, which is start from 1 and find till possible. Okay, and what we have to do, return the smallest integer x, missing from nums such that x is greater than or equal to the sum of longest sequential prefix. Okay, so from this, whatever be the sum let it be x of prefix array which we have formed. Okay, and we need to find x y such that it is not present in nums and y is just greater than x. Suppose the sum is x, but x plus 1 is present in nums, so x plus 1 cannot be considered. We need to move forward and check whether it is present in nums or not. If it is not present, then we will return it. So let's first understand with an example. Suppose we are given nums equals to 1 2 3 2 5. Now initially our pref array will by default have nums 0, so as of now it is having 1. Now we will start from 1. Okay, and check whether nums of j equals to nums of j minus 1 and plus 1. Okay, so for j equals to 1, 2 equals to 1 plus 1, so we will insert it. So our prefix will become 1 comma 2. Now for j equals to 2, we get that, okay, 3 equals to 2 plus 1. 3 is, okay, nums j equals to 3 and nums j minus 1 equals to 2, and 3 is equals to 2 plus 1, so we will add 3 as well, so our prefix will become 1 2 3. But now when j will become 3, nums of j equals to 2 and nums of j minus 1 equals to 3, and we noted 2 is not equals to 3 plus 1, so we will break it. So if we find a particular number, we should go further? No, we will not move further, because if we move further, it will no longer remain a prefix, but rather it will become a subsequence. Okay, now we will find sum of whatever our prefix was 1 2 3, and its sum will become 6. So we will check, okay, is 7 a number just greater than sum is present in the array? We can say, oh, 7 is not present, so our answer will be 7. Okay, let's take another example. Okay, okay, my way, guys. We need to find a particular number y which is just greater than or equal to x. Okay, so here the answer will be 6. Let's take one more example, which is 4, 5, 6, 9. Okay, prefix will initially contain the 0th index, which is nums of 0, which is 4. Okay, now for j equals to 1, nums j equals to 5, nums j minus 1 equals to 4. And we know that I equals to 4 plus 1. So we will push it. So the prefix will become 4 comma 5. Similarly, for j equals to 2, it will satisfy. So it will become 4, 5, 6. Now for j equals to 3, 9 is not equals to 6 plus 1. So we will stop it here. So our prefix is 4, 5, 6. Sum is 15. And we will check first. Okay, 15. 15 is present in nums. So we will try for 16. 16 is not present. So 16 is the answer. Okay. So what is our approach? Is that we will not form, first of all, we will not form the array, but what we will do is we will consider, suppose there was an array. We can say that prefix array sum equals to nums of 0. Why? Because in both the examples, we have considered the first element, and that element is finally used to calculate the sum. So instead of finding the array, why not we just calculate the sum along the way? So prefix sum will be nums of 0, initialized to nums of 0. And for j, we will iterate from 1 till end of array. And in that, we will check if nums of j equals to nums of j minus 1 plus 1. Okay. If that's true, we will do sum plus equals to nums of j. Or if it is false, what we will do is we will break, because no more prefix can be calculated. Now, while we find answer greater than equals to sum, we check if that candidate is present in nums. True. Next candidate. False. Return candidate. Okay. Okay, and how we will check if that particular candidate is present in nums or not? So for that we can store particular elements of nums in a set to just maintain check if present or not. Okay, so let's move to the implementation part. So let me make it bigger, and this is smaller. Okay, we will initialize with first element. Okay, so int sum equals to nums of 0, and we will iterate for j will start from 1. For int j equals to I, j less than nums dot size and j plus plus. And now we will check if nums of j equals to nums of j minus 1 plus 1. That's the case, sum plus equals to nums of j. If that's not the case, which means that okay, this will not satisfy, and we will break the suffix here. Now what we will do is we will use unordered map or unordered set, which will store the elements of a nums. Why? Just to check if that particular element is present or not. So while first we will insert nums element. Okay, for auto and val nums s dot insert val. Okay, now what we'll do is while s dot find sum not equals to s dot end, what we are checking is that if our candidate is not present. Okay, till it is present, till that particular candidate is present, we will check sum plus plus, and then we will, if this condition breaks, it means that our candidate is not present in the set. If a particular element is not present in the set, the find function will send the iterator of the end. Okay, now we will do the sum, return the sum. Let's check first if this is correct. Okay, okay guys, the issue was here. We this break should be in the else part. Let's check if there is any issue. And here also it should be, I guess, not equals to s dot end, because not equals to s dot end means that it is present. Okay, let's first run it. Okay, now submit. Now let's first find the complexity. This complexity will be O of n because it is a one for loop only. Insertion will not take much of time because numbers are small and less, so it will be O of 1, and this will be O of n, and finding will also be almost O of 1. And so yep, so the entire video approach will be O of n and O of n in both the time and space complexity. I hope you guys understood, and if you have any doubts, do let me know.